Hello. Hello. Am I audible? Hello.
Yes, sir, you are audible.
Okay. Okay. So good evening, all participants. So today is the second day of our FDP. So now in this session, we have with us expert speaker, Dr. Josna Devi Bodapati. So Dr. Josna Devi Bodapati is a distinguished researcher and academician with over 16 years of experience spanning industry, teaching, and research. She is currently serving as an associate professor in the Department of Advanced Computer Science and Engineering and as the head of content training at the School of Computing and Informatics at Vignan's Foundation of Science, Technology and Research. She holds MTech and PhD in computer science and engineering with her doctoral research focused on deep learning and attention-based neural networks for medical image analysis. From 2013 and 2016, she worked as a full-time research assistant at IIT Madras, where her work focused on integrating semi-supervised learning in sequential models and the application of deep learning techniques for machine translation and medical image analysis. Dr. Josna's ongoing research explores attention-driven neural architecture, semi-supervised and unsupervised models, and deep learning strategies for visual captioning and image understanding. She has authored over 60 research publications in reputed international journals and conferences. Her remarkable contribution to artificial intelligence and machine learning have earned her recognition among the world's top 2% scientists by Stanford University in 2024 and 2025. A passionate academician, Dr. Josna regularly delivers expert talk at prestigious institutions including NIT Chandigarh and Maulana Azad National Urdu University, Hyderabad, a central university. Her commitment to integrating AI-driven innovation with real-world applications continues to make her a leading voice in advancing research and education in artificial intelligence, machine learning, and data science. So you are requested, madam, to start the session now. Please, madam.
Yes, sir. Thank you, sir. Thanks for your generous introduction. A very good evening to all the participants. I'm audible.
Yes, madam. You are audible.
So, thank you, sir. Share my screen. A very good evening to all the participants. So I'm Dr. Josna. So my session is on OpenCV for computer vision. So as the organizers intimated me, it should be a full hands-on session. I'll give a very brief introduction about computer vision, then we'll move on like OpenCV's demonstration. And the outline of the session is, so I'll just give a very brief demo of what computer vision, and for those who are not having any idea about the computer vision, and then how to install OpenCV, then what are the basic operations that we can perform, like how we can perform the very basic operations on images. So some basic operations, the image processing operations that can be done using OpenCV on the images, then some advanced operations like key point detection, template matching, and few of the real-time applications like panorama stitching. So how we can stitch two images into a single image, then identifying or detecting the face image, the face part, face region from the image. Then in addition to that, we'll also see along with the face, can we detect the eyes, the region alone. So that's what we'll detect. And not only from the single image, we'll also see how we can do it, extract the face regions from multiple images also. So this is the outline of this session. let's start the session by understanding what computer vision is. So this workshop is itself is named as like computer deep learning for computer vision, right? Yeah, computer vision can be achieved using machine learning or the deep learning as well. And today's session and tomorrow's session, so today's session is basically uh, like based on the image data, and tomorrow's session will discuss how to work with the videos. So that's how I planned it. So tomorrow also one of my session is scheduled. So let's start with understanding of the computer vision. So what is computer vision? So we are trying to give some vision capabilities to the computers, the computing devices. So if you can give such a capability, like we humans can visually understand, right? So you can see, you can understand, not only look at, you can watch, you can also understand the scene. And if the similar kind of capability can be given to the systems, then such kind of computing systems are known as a computer, that if you are giving that ability, that's what the computer vision is. And this image vision could be of different forms. That is, vision here refers to the data, and visual data refers to either video or the image, or it's a depth, like a still image, or like motion image, or like multi-dimensional data also if you consider. So that's what the vision indicates. And here, not only like looking at the images, not only about the loading images, computer vision means so you are making the systems to understand and to analyze the uh, data that is available in the images. So if you look at this image, so when you apply a model on this, so the computer should, or your model should be able to say that so there was an accident. So that's what the understanding we can get from the image. And in the background that we can see an ambulance also. So that's what the understanding is. So we are expecting our systems to understand the images and to analyze the image, and that will be ultimately lead to the taking the decisions, the future, for the future purpose. So that's how we would like to achieve the computer. That's what the computer vision typically refers to. So here, what is the object of the computer vision? We are making our computers to understand the images. So that understanding could be in different senses. Like, so given this image, we are trying to understand the questions like maybe the kind of scene, what kind of scene it is, or what kind of image it is. Or if you can see, there are few cars and there is a house, there are trees. You can see it's in the resort kind of, right? So what kind of the scene is? The scene refers to the, or it is representing a resort. And you can see there are few cars that are parked. And how many cars are? Where are the cars? So once your model understands the image, then it should be able to answer all these things. So where are the cars? Where are the cars? And how many trees? So this kind of how the weather is. So all these questions, the model should be able to respond. Such kind of understanding you are expecting from the computers also. And of course, we humans can easily understand from the image, right? Like without any delay, we can simply straight away say that this scene is referring to a resort, a building is there, there are few cars, all these things we can, without any difficulty, we can say that. But how can we make our systems to say that? That's what the difficulty is. And why is it a problem? And what is the difference between the computer vision and the human vision? So the basic difference is if you observe this image, what we humans see is like this, right? The image we can see. But whereas if you pass the same image as a digital image, the digitized version of the same image, what the computer can see is only numbers, right? So that's the basic difference between the computer vision and the human vision. So humans can straight away look into the image, but the computer can see only the numbers, and from that numbers, it has to do all the understanding and the analysis part of it. And why this computer vision is so hard? So why do we need like image processing techniques or like machine learning techniques and deep learning techniques, advanced algorithms and all the generative AI-based approaches? So the reason is there are certain challenges when it comes to the real-time applications of the computer vision. So computer vision is really hard because of these reasons. So that could be a variation in the viewpoint. You can see this car image. So all these images are referring to the car images. This is side view of it. This is the frontal view of it. This is the backside view of it, right? So if you consider a person, maybe a car, we can easily, or the model also can easily say that this is a car. And if you consider, we humans can recognize a person from the background also, backside also, right? Without any delay, we can say that. Even even if there are 100 cars, we can easily remember or recognize our car. So that is the power of the human vision. But how can we make our computer also get this kind of vision? So that's what the computer vision is dealing with. So this is one of the challenge. So the variation could be in different different viewpoints it has to deal with, and then the illumination means the lighting conditions. Here the same image you can see. So but the lighting conditions are different. So this is also a challenge, right? So here you can easily recognize this person, and here it is very difficult and scary. And maybe these are two different versions, and here you can see. So the laptop could be of this size or this size, and the person could be of this size or even this size also. So that's a scaling differences. So this is another reason for the difficulty of the challenging part of the computer vision. And maybe there are a few other reasons why computer vision is so hard is like interclass similarities and intraclass variations. So what is an interclass? So interclass means like here if you consider all these images, they're belonging to some politicians or celebrities, sportsmen, right? And I would like to divide this into two classes. Maybe one is like male class, female class you can, or otherwise like sports persons and the politicians you can. So you can divide it based on different things, right? And maybe here we are considering this as one class and this is the other class. The celebrities as one class and sportsman as another class. So considering that here, interclass similarities and there are some interclass similarities. What is this interclass similarities? So though these two are in the same group or same category, so it's a male person, it's a female person, right? And intra-class variations. Here you can see across the classes also there could be some overlap. So that is the problem. So here, so there is inter-class similarities between the classes. So though they are belonging to different classes, there could be some similarities. So that is what the inter-class similarities is. And intra-class variations. Intra-class variations is, so though they are belonging to the same class itself, here you can see all these are belonging to the same class, but there are a lot of variations in all these different images, right? So that is what the intra-class variation is. Maybe in terms of the illumination, there is difference, and facial expressions are different, and the pose is different. So all these comes under the intra-class variations, and this is another major reason for the difficulty or the challenging part of the computer vision task. So that is how like even the modern systems also are struggling for achieving the computer vision tasks. And here you can see intra-class variation. So within the same class, these all belonging to car only, car class only. But you can see this model is different, this model is different, and this model is different. But all are belonging to the same class, right? So that's what the intra-class variation is. And the motion. So when you are especially applying on videos, so motion is the biggest problem. That is why like computer vision is difficult than occlusion. We can see, of course, here at least we can see there is a cow. But if there is something like a chameleon that is here, then identifying that will be a difficult job. So occlusion is another problem. And the background clutter. Here you can see there are foxes and background and the foxes both are in the same color. The color variations, there is no much difference, right? So these are all the problems or the challenges when it comes to the computer vision. And where do we use the computer vision is you can use it in the safety applications and healthcare applications, maybe in security applications to identify the theft or to identify any um, unexpected events. And in entertainment, you can use it. So, and in video games, like for fun, you can use computer vision tasks. And for accessing, like for you can use your all of us we are using, right? Our facial recognition or the like fingerprint we are using, or the even voice recognition we are using to access to our mobiles or our gadgets. So these are like very few basic applications where we can use the computer vision in real time. Why we are discussing about OpenCV and what this OpenCV is. So without much delay, So maybe there are several other talks that are scheduled on computer vision. So I don't want to go into the details. I just have given the overview of what the computer vision is. So I will be focusing mostly on the OpenCV tool and how it can be used for the computer vision. So let's have a brief note on OpenCV, and then we'll jump on to the demonstration of the OpenCV applications. So what is OpenCV? So OpenCV is like CV here stands for, you can see, so CV stands for the computer vision. And why OpenCV? So why we call it as OpenCV is it's an open source for the computer vision library. It's an open source computer vision library, and shortly it's named as OpenCV. So this is the open source library for the computer vision, and it also allows you to the machine learning and the deep learning based applications. And there are around 2,500 optimized algorithms for various real-time tasks, like you can do the object detection. And tomorrow's lecture we will be discussing about this object detection and the object tracking techniques. And then we have image stitching. So in today's lecture, we'll see what is image stitching or the panorama stitching is. And you can even recognize the human actions from videos or from images, and you can recognize the faces, you can recognize various objects. So you have such kind of algorithms. For all these regular applications, we have several algorithms which are very, very much optimized, and they're available, pretty much available in OpenCV. OpenCV is basically a Python library. Yeah, of course, it is extensively used by tech giants like Google, Apple, Microsoft, Intel. So that is how it became so popular. And it has the compatibility with other programming languages also, like C++, Python, Java, and MATLAB. So that is why it's popular, and it's pretty much easy for you to understand it. Pretty much easy to understand and also easy to use it. And it supports other cross-platform independent, and it can be used without any deviation across different operating systems. Like you can use it in Windows or Linux or Android or Mac, any of the operating system, you can use it without any difference. So that is how it became so popular. And how we can use it for basic image manipulation or the basic operations. So before we proceed into the applications of the OpenCV, we will see how to import it. So you can import it using this command, pip install OpenCV config Python. This is how you can install it. And once you install it, you have to load it. So here you can see how you install it in Ubuntu, and this is how you can install it in Windows and in Linux or Ubuntu based operating systems. So you can use sudo apt-get install Python, and you can even use pip, the Python installation manager also you can use, like sudo apt-get install Python for pip. This is how you can install it. And once you install Python, then you can install OpenCV using pip install OpenCV config Python. So these are the commands you can use for installation. So now let's move on to the demo. I would like to show the demo in Colab so that it is more convenient, and quickly I can run it and show all the symbols and the demonstrations we'll see in this session. Yeah, here you can see we can install this is the command, you can use it. And when you are installing in Colab, you have to use like pip install OpenCV Python, and the not symbol you have to use it. And whenever you install the command in Jupyter. So once you install it, and of course Colab comes pre-installed OpenCV, so you need not to again install it. That is why we are getting this command requirement already satisfied. So once you install it, you have to load it into your Python environment, and then only you can use it. And how to load it is you can use import cd2. So once you load it, so you can do whatever the operations you would like to. The library is now available for your usage. Now let's see how we can make use of it. I'll start from the very, very basic operations, and gradually I'll implement the complexity so that every one of you, those who do not have any basic understanding of the OpenCV also can understand. That's how I made it today in the session, because tomorrow we'll be looking at object detection and object tracking also. And today we'll be looking at few of the applications of OpenCV, the real-time applications like face detection and panorama stitching, then template matching, all those applications. So I thought like if you can, we can do it from scratch. So all of you can come to the same level. So now let's see how we can load an image using OpenCV. So to load an image in OpenCV, we use the command imread. So imread is the command which allows you to read the image or to load the image into your Python environment. So here, wherever we are using CV2, already we installed, right, CV2. And hereafter, wherever you are using CV2, that means the functions are part of the CV2 library. So imread is a function of the OpenCV module, and this imread method takes two different arguments. One is a string, so the string which indicates a path. So it could be a full path or the relative path, that depends on where your image is. And the second is a flag which tells you, so how, like, it's a flag basically. So like what kind of image you are reading, whether you would like to read it in a grayscale mode or the color mode or what it is. And you can pass an integer as a second argument. Here I'm not passing anything. So when I don't pass anything, then it will be using 0 as default, which indicates that the image is read as the grayscale image. And you can set the argument as 0 or 1, the second argument basically. So 0 stands for the grayscale image and 1 stands for the color image. And we have 3 different parameters that can be passed. Rather than passing the integer value as a second argument, you can use imread color, imread grayscale, or imread unchanged. So imread color indicates you are loading the image as a color. You are loading the image as a color image, and this is by default basically. And when you pass the imread grayscale, that means you are loading the image in the grayscale. We'll shortly see that also. And these are the 3 different arguments that you can pass as a second argument. Okay. So now, once you load this, I will be showing this thing. This is actual image, and I hope all of you know how to use Collab and all. And basically, my images are available here. Yeah, this is the image I would like to do. Okay, I'll shortly show you the image also. Now here you can see, once you have loaded the image, it is into the object image. Now I would like to check the shape or the resolution of the image, and how do we load the image. So if you observe, this image is basically, when you load it, it's loaded as a 3-dimensional array object, because by default the image is loaded as a color image, and my image also is a color image. And here you can see, I'll show you that. You see, it's an NumPy array basically, and size of this image is 340 by 557 by 3. Show you the properties also. Here you can observe that. Where you can see it's 557 by 340, and we can understand it's a color image, right? Yeah. So now you can observe and how do we understand that? So here I'm showing you, and how can we check, like here in the program, how can we check the size of the images? We can use a shape operator of the image object. Shape operator you can use to retrieve the shape of the image. Thereby you can understand the image is of size 340 by 557 by 3. And please understand that here it is the way it is loaded is, it is not first the channels. Basically in other libraries, it will be loaded as 3 by 340 by 557 or 3 by 57 by 340, right? So first argument would be in MATLAB also, it would be the first argument is 3 channels and then the height and width. But in OpenCV, it is little different. So in OpenCV, your width and height of the image will be read as first 2 arguments, then the channels. And in OpenCV, always the color channels are blue, green, red. So that is what the color channels, that is how it is used in OpenCV. So now I would like to see the image. Here you can see this is what the image is. And how do we display this image? So you can display the image by using IMShow of CV2. So typically here in Collab, I can simply call it as image, but In your Jupyter notebook, you cannot say that. You have to use the I am show method to access or to load or to present your image. So the method that you can use is CV2 underscore I am show. So this is the method you can use. Or even you can use CV2 dot I am show in your Jupyter notebook. Basically, in Collab, it doesn't work. You have to use CV2 underscore I am show method to present the image or to visually display your image. And this is what you need to load. You have to load the CV2 underscore I am show from Google Colab patches of this library. You have to load this one. And using that method, you can load the image. And this is how your image is. So now your image is shown physically presented. So now let's go ahead and see how do we convert. Now, Asian, my image is in color coded, and I would like to convert that into in my program. I would like to do that, changing into the grayscale. Then how do I do that? So we have the method CVT color in the OpenCV library, and the colors can be changed to either basically it is BRG, right? So the color channels are BG in OpenCV, and you can change it to whichever color code you want. So you can use BRG or HSV or like BRG to RGB. So whichever color codes you would like to, you can change it. And if you are changing from BGR2, so here in this case, our image is BGR, and that means blue, green, red. These are the color channels. And I would like to convert this to the grayscale. And for this, I can use the method BGR to gray. So now you can say and call the method. Here you can see again I'm loading basically. So I'm loading the image, and while loading, there are two ways to get the image as a binary image. Though my image is a color image, I can, by loading itself, I can load it as a binary image. And for that, we can pass a 0 to the IMRead method. Okay, and this is how I can load it. And this, and here you can see the shape. And when you extract the shape of the image, when you retrieve the shape of the image, we can say it is 340 by 557. So there is no third dimension because it's a grayscale image, right? Yeah. So that is what it is. And this is how you can load the image itself by passing a 0 to the IMRead method. That is one way. And what is the other way to convert the image into grayscale? Already the image is loaded, and I would like to convert that into the grayscale, and that can be done using CV2.cvt color. And here the first argument should be your image, and second argument is like the color channel specification. So from which channel to which channel you are converting, that need to be mentioned. So basically in OpenCV it is BGR color channel, and we are changing it to gray color. So that is how you can get the gray image. And the gray image we are presenting it here by using IM show. So that's how you can. So what we have seen so far, how to install OpenCV, then how to load an image in our drive, and here because it's in Collab, I'm showing it from how I can load the image from my Google Drive, and here you can observe this is the path we are using, and either you can use the full path or the relative path depending on where your image is located. And then how to load a color image, and how to load a grayscale image we have seen, and how to convert the color or change the color of an image from color to the grayscale image. That's what we have seen. And then, say for example, if we would like to save the image, so I have an image, I have loaded it, and I would like to save the image. Then how can I do that? I can do that using IMWrite method. So here I have the image gray. Gray image is the one which is this one, and I would like to save that image, which is loaded in the variable gray. And this can be done using IMWrite method. So IMRead is for reading, and IMWrite is for saving the image. And you have to pass the first argument should be your image that you would like to, the name of the image value you would like to show, save, or the full path you can pass, and then your Python object where the image is loaded. That's how you can save the image. Yeah, and here you need to understand that when you are saving the image, whether it should be saved as a JPEG image or a PNG image, that is. So here we are saving the image as .jpg, or you can even save it as .png. So this is how you can do. So basically, why am I going into all the details is tomorrow's lecture will be seeing about the videos. And when you are processing a video, it's all about the frames only. So you have to first change the image into different video into different image things, and that is what maybe you need all these things. Yeah, I thought like these are all very much important. So then resizing or scaling of an image. So if you would like to resize. Here, my image size, what is the size of my image? It's a binary image. When we load it as a binary, it is 340 by 557. And when we load it as a color image, it is 340 by 557, right? 3, right? And I would like to change it. The shape of the size of the image, I would like to change. Then how can I do that? We have the method in OpenCV that is resize. So resize, you can use it. And you have to pass two arguments. The first one is image, and the second one is the resolution of to which size you would like to. So basically 557 by 340 and changing to 500 by 300. So then you will get the resize image. So again, I'm loading the image from the scratch. I'm loading the image and then I'm converting the image. Okay. So then you can see, you can present the image using I am show, and here is it. Yeah, this is the original. I'm presenting both actually. So this is 340 by 557 by 3 image, and this is like 300 by 500. After rescaling it, it is 300 by 500 by 3. This is how we can change the scale of the image. Can you see? So this both height and width are reduced. This width you can understand. This is how we can change the shape of the image or the scale of the image. Now let's see how do we flip the image. So flipping is you can do the flipping in horizontal manner and the vertical manner.
Excuse me, ma'am.
Yeah, please.
Can you please just once again show the reshaping changing the size of the image once?
Yeah, here. CV2
Yeah.
dot resize.
Dot resize. Okay.
Yeah, resize.
Okay. Thank you, ma'am.
And we are going to see the flipping an image. So why do we need all these basic operations? Is the image operations is we need to understand all these because nowadays when we are using the deep learning algorithms, they are data hungry, and when we do not have much data with us, then what do? We apply augmentations, and we are all doing it without any understanding. So basically, we need to understand what kind of basic image processing techniques we can use to do the um, augmentation of the data. So we use like flipping and resizing, the scaling that we just have seen. And then I'll show you a few more other operations that we can use. We can use the Gaussian blur, all those things. Yeah. Now we are going to see how we can flip an image. So you can flip the image using flip method of the CV2. CV2 stands for the OpenCV basically. Don't worry about it. And CV2.flip method, and you have it takes two arguments, the image and the second one is whether you are doing the vertical flipping or the horizontal flipping. First, I'll show the output, then you can better understand. So this is the original image, right? This is the original image. It's like sitting on a wall. And when I do the vertical flipping, you can see it's flipped upside down, right? Yeah, that's what the vertical flipping of an image is. And horizontal flipping also it is. And in your original image, where the cat is sitting towards the left of the image. And when I do the horizontal flipping, you can observe it's sitting towards the right side of the image. And that's what the horizontal flipping is. And how we can do that? We can call the flip method by passing the image as a first argument. And a second argument could be either 0 or 1. And 0 stands for the vertical flipping and 1 stands for the horizontal flipping. That's how we can do it. So here I'm doing the vertical flipping by passing the image along with the 0 as argument. Here you can see, observe, right? Vertical flipping, upside down. And horizontal flipping, right to left, you can see. So right becomes left becomes right. Okay, it's kind of, yeah. So CV2.flip of the image, comma 1. So this is what the horizontal flipping is. And we are going to see how do we do the reversing of an image. So this is also called as the inversion of an image. We can either call it as an inversion or the reversal of the image. And what this, yeah, so for you have seen the original image, right? This is the original image. And if you look at this inversal operation, it's how it looks like. And what is happening basically in the inverse operation, and the method you can use is of course bitwise mod. But let's understand what is happening. Why this is this kind of appearance change. because basically every pixel is a combination of three different colors in a color image, right? And the values could be at every pixel size. Pixel, there are three channels, red, green, blue, right? And every pixel is having a couple of three values. So this 255 stands for BGR, right? It's a blue, green, and red. So in OpenCV, when you load an image using color with color image, then it is every pixel is represented using three tuples, like three valued tuple. So it is a blue color, the first one in the tuple, second one is a green, and the third one is a red color. The BGR representation of a pixel. And now when you apply this bitwise not operation, what happens is the value, the corresponding value of a pixel for every value in your tuple, it is reduced from 255. So 255 minus this 255. Then 255 minus 0. 255 minus 0. That's how it happens. Now if you subtract 255 from this tuple, a tuple with all 255s, then what happens? The resulting tuple will be 0, 255, 2. Right? This is what we get. This is the resultant image, the resultant pixel value you get. And the same thing is applied across the entire image for all the pixels. And that is where we are getting this kind of image. So what is your original image? You can observe this is the original. And now what we are getting is this. And why is that happening? So from every pixel, where the pixel is represented using BGR color code, and it is we are subtracting a tuple of all 255s. So that is how it's happening. You can see here. For your understanding, I have written everything here. I'll share you the notebook so that you can go through every detail of it and can better understand it. Yeah. Now we are going to see like blurring of an image. So these are all the those who are like familiar with deep learning can understand. So they do all these things even without knowing what blurring is, what transpose is, what translation is, what scaling is, right? That's what we are trying to understand. So blurring an image. How do we do the how do we introduce blurring an image? So we are kind of introducing the noise into the image. When we are doing the blurring, means we are reducing the details of the image by introducing noise into the image. That's what the blurring of an image. And how do we do that? So how do we do the blurring using OpenCV is you have the blur method, and of course there are different kinds of methods that you can use. The basic version is a blur method you can use, and it takes the arguments like image, on which image you would like to apply the blurring, and then the kernel width and kernel height you can pass, or a kernel you can pass. Okay, yeah, here it's a 3x3 kernel size I'm using, for example, on the cat image which we loaded earlier, the color image, and we are passing a kernel size of 3x3. So kernel means a filter we are using. In convolution neural networks, we use the filters, right? And the same way we can apply the operation as a 3x3 filter size we are mentioning here. It can be like 5x5 or 7x7 also. And when we blur it, we'll be getting the blur image. And I'm showing you for your understanding, this is the original image and this is the blurred image. Can you see what we lost here? The details are lost if you observe. Can you see? The sharpness in image is lost. This is, of course, this is another version of the image, right? That is where the data augmentation will be helpful. So later on, in your testing, when you are inference stage, if your image is not that clean and clear also, your model works perfectly. So that is where you are using all these data augmentation techniques during the training. Sorry, to enhance your data set, and then we'll use it for training. So now, so why do we do this blurring, by the way? So the reason we blur the images to attend to more important details. If you observe clearly the original image of this, what is more evidently seen? Of course, the object here is cat, but sharply you can see these details. Can you see? These are much more evident than the cat, if you clearly observe, right? But after doing the blurring, what is more evident? The sharpness has gone, right? So to get the focus on to the important objects, so we use the blurring. So that is where the blurring is helpful. Okay. And we have seen the basic blurring, and you can even do the Gaussian blurring also. Here I'm showing you the Gaussian blurring, and I'm increasing the channel size so that the blur effect is more. You can change this kernel and you can get the blurring, whatever the kind of blurring you'd like to get. Okay, and this is what the Gaussian blurring we are applying. You can observe as the original image, and this is the like after introducing Gaussian blur into the image. So this is how the image looks. Now we are going to discuss about the morphological operations like dilation and erosion, and these are also very very important for a few of the image processing applications. So let's see how we can use this dilation of and erosion operations. These are the basic morphological operations, and why do they? When do we use it? As, or what is the objective? Is to expand the white regions of the image. Especially when your foreground is white, then to expand the regions, then you can use the dilation. And rather than showing you on this image after applying the dilation, this is the original grayscale, and this is after applying the dilation. And you see there is a difference, right? But maybe for this image, it is not much meaningful. We are losing all the details, but I'll show you an application, an image where it is better used. And you see here, this is the J. It's only a binary image. And dilation and erosion, these are applied on the binary images or the grayscale images. Okay. And here, the white region, and it is after applying the dilation, it is more evidently shown, right? It is enlarged. So to enhance the white regions on the background of the black, you can use the dilation. And I will show you a better example after applying this erosion and dilation. Yeah, you can see. So when your image is having some text like this, OpenCV morphology, this is the text. Maybe in some part of the image, and I would like to like better understand or extract the text from the image. Assume that the letters are like overlapping or like they are not that clear. Then by applying the dilation, you can see the sizes of the letters are increasing so that they are better visible. And erosion. So erosion, after applying the erosion, you can see this. And erosion is the reverse effect of the dilated effect. And what happens when you apply the erosion operation is, so in case of dilation, the white regions are enlarged, whereas in case of the erosion operation, the white regions are shrink or compressed. Then what happens is, say for example, in your original image, the characters are overlapping, and the model is unable to understand the actual characters because they are all merged together. So that is where the erosion will be helpful. So it shrinks the white region so that your text is much visible without overlapping. So this is the real-time application of this erosion and dilation. So those who are working with the text like OCR, optical character recognition, for them it is much more important. These operations are useful. Yeah, now let's see how we can apply these operations. So if you see the application, then you will get better interest. Right? The dilation of an image. So what this dilation operation is? The dilation operation is enhancing or expanding the white regions on a black background of the image. Especially, please understand, these are applied on grayscale and the binary images only, not on the color-coded images. That is where I'm loading the grayscale image, you can see. And for the dilation operation, you can use the method dilate. And for the erosion operation, you can use the erode method. So dilate is the method of OpenCV, which allows you to apply the dilation operation. And what are the arguments you need to pass? You need to pass the grayscale image or the binary image. And the kernel you created. You can apply your own kernel. And here I'm creating a kernel using NumPy. So in NumPy, I'm creating a 3x3 array with all ones. So you can have your own kernel and you can see the effect. Okay. And when I apply this kernel on the original image, the grayscale image, so you can observe this is the original image and this is the dilated image. I'll show you the kernel also. What is the kernel that we applied? Let me run this and show you. The kernel that we applied is all parts. Just for the sake of simplicity, I have created. Like you can try whichever kernel is, like what is the impact of different kernels you can try. Now you can see all the white regions are expanded so that the details are gone here actually. Now I have already shown you, right? Like wherever the characters, when you are working with handwritten character recognition or the optical character recognition applications, so you can better use this dilation and erosion. So when the objects are like not clearly visible, when the characters are not clearly visible, then you can use this dilation operation to expand it and then you can visually see this, right? Of course, here J is clearly visible, but in case if you have any such kind of, then yeah, here you can see this dot and this are merged together. Sorry, they're not, they're separate here, but it is merged, right? It's actually like destroying the details. So whenever it is too thin, then you can use it. Otherwise, you do not. And the erosion operation, so it's a reversal of the dilation operation. You are basically shrinking the object boundaries. Okay, and now you see how it is. Yeah. So you can see this is how the J is, and after applying the erosion operation, it looks like this. So when the characters are like you have large set of characters and they're overlapping, then you can use this. And what is the operation you are using? Erode is the method you can use. In computer vision, you can use erode method. Okay. The image you can pass, the kernel you can pass. And the kernel, it's here I'm passing 5 by 3. And earlier I have used like 3 by 3. And whichever kernel you like to, you can design it and can check which is suitable for your application. You have to check. And here you can see on the original image itself, I have applied actually the erode operation. So when we apply erosion on the original image, it's actually losing all the details. And of course, this is because of my kernel I have used. If you use the proper kernel, it not lets. So this is how you can do the erosion and dilation. Okay. And on real time, like OCR application, I have shown you how the dilation and erosion have the impact. Basically, the number plate detection operation. So on the vehicles, if you would like to extract the part, and when you capture the images, so while the vehicles are moving, running, so then you may not get the clarity of the characters, right? That is where the dilation and erosion operations are much useful. Yeah, this is an application you can consider. Yeah. Now the next operation, the next type of operation is the translation operation. So what this translation is, you are going to translate, like move the position of the image. Yeah, I'll show you the output so that you can better understand. So this is the original image and you can see. So we are moving the actual content of the image. Okay. So that is what the translate. You are placing from this location. This is the starting point of the image, right? So I'm dragging this starting point to here. So of course, in this, I will be losing like part of the content that is there. So this is what the translation is. So you are basically shifting. So you are not like, dragging or something. You are placing the entire object not from this location. You are placing that from this location. That's what the translation is. And for the translation operation, you have to create this translation matrix, and then only it will be applied. And this Tx and Ty indicates the X and Y coordinators of your destination image. Here, if you observe, there's something like 100 pixel and 50th pixel, right? Why? Because I have notified that my Tx and Ty should be 150. So with that, I'll be creating a translation matrix, and that need to be passed to this translation. And here you can see this translation can be done in OpenCV using the warp affine. So warp affine is the method which allows you to translate the image location, or shift the image location to a required coordinating position. So now this is the original image, and this is the translation matrix, and this is the width and height. Okay. So the total image, of course, is the original entire image, and this is what the translation parameters are. Okay, Tx and Ty I'm setting to 150. So that's how this is the point, starting point of the image. This is how you can shift the image. Now we are going to look at the geometric transformations of the image, and of course, all these operations are very much useful when you are applying augmentations for your deep learning models, when you are working with the computer vision and you are working with various augmentation techniques of your computer vision model, then it will be useful. Then the geometric transformation. So what is this geometric like, let's see how this geometric transformations can be applied. It's an affine transformation you can apply, or you can apply the warp like perspective transformation also you can apply. So what we have seen just now is the affine transformation, right? Or the warp affine transformation we have done. If you observe, when you move this or the shift the position, then this is how the image is placed. And it need not be with the same, you can rotate it and then shift also. Okay. Somebody is having any doubt, or I think some message was there, and I'm not looking at it. So if it is really needed, you can interrupt me and then you can talk to me. It's not a problem.
Hello?
So now the yeah, please.
Ma'am, I have confusion augmentation, ma'am.
Yeah, please. I'll try to clarify that. Please tell me. Hello, what is your doubt?
Ma'am, the flipping the image and the other part of image is under the augmentation process.
We do that, right? We can. How do we create the augmentation techniques, like data augmentation? When we are
Yes.
enhancing the data, we do the we do apply the augmentation techniques. And how do we augment the data? We apply various image processing techniques. So by flipping or rotating or scaling, translating, these are all the techniques that we use.
Okay, ma'am. Okay, ma'am. Okay. Thank you, ma'am.
So now let's see the affine transformation. So when we do the affine transformation, like the warp affine transformation, you can see this is how there are black regions that we get. And we can do the perspective transformation also. So what is this perspective transformation is? So rather than simply rotating the image, and we can say, for example, this is what the region I would like to do the transformation. And by doing the transformation, I am trying consider this as the original image. Okay, and this is my actual after rotation, and I'm not rotating the entire image. Only part of the image I'm going to rotate it. And these are the coordinates of the image. We can see. So your A becomes your starting point, and your B becomes this, and your D becomes this, your C becomes this. Okay, and this is what the transformation I'm expecting. And this transformation we call it as a perspective transformation. And what happens here is, so we'll be preserving the parallelism, length, and angle of the images. Okay, and of course, sorry, we do not preserve the parallelism, length, and angle, but we preserve the collinearity and the incidence of the images. And that is what the transformation we call it as a perspective transformation. Okay, and I'll show you an example where we can actually use it. And can you see this? This is the image. Maybe I'm applying the OCR on an image like this. You can see this is the original image. And can you observe any difference between these two images? This is little bit tilted, right? And this is like, you can understand this image is little kind of frontal view. And this is taken something like side view of the image, right? And after applying the transformation, the image is better, visually it is better, so that it is taken, you feel that it's not only feeling, it's like taken from the frontal view. So to get this kind of effect on the images, we apply this kind of perspective transformation. And how do we do that is, of course, it's not that easy. We have to identify the points and the angles. So we have to prepare these three. I have done a lot of exercise to do that. So you have to create these kind of matrices, and then you have to pass them to the get perspective transform, the input points and the output points, both you have to pass. And then you have to call the warp perspective on the image, and this perspective, get perspective transform object. So the object that we created, we have to pass it. This is the original image. And this is how we get the warp perspective. Can you see? This is actually taken from the side angle. But we are converting that image so that to get the illusion that we have taken it from the frontal image. So frontal view. So that's the difference between the original image and the perspective transformed image. That is where we use it. And I'll show you my here you can see the actual application that you can see. Of course, I could not completely do it. At least somehow I could manage that. So this is the original image. So after applying the transformation, you can see the image looks like it is taken exactly from the frontal view. And so that not only like you are getting that illusion and you are getting that view, you are able to now read the characters also, right? You zoom in, maybe you can read the characters. Better read the characters, right? So this is what you're doing with the help of the perspective transformation, right? These are the applications where you can use it. Now, say for example, if you would like to load the images from the web somewhere, the image is available. Basically, I have taken this image from the online source. Say for example, this image is available here at this location. So some online location I have seen, and I would like to load this image into my Python environment. And how can I do that? So you can use this code, this part of the code snippet. You can use not wget. You can use this so that it will be loaded. And once you do that, you can. So from this location, you would like to read the image. So this is how you can read the image. Okay. So this is how you can read an image from the online sources also. See, this is the image we are loading. And of course, I have already shown you, right, how to save the image. You can save the image using a, right? We have already seen that. And then thresholding. So you can apply the thresholding operation. So what this thresholding does is it will be removing some unnecessary details if there are any in the image. And what is this thresholding? Basically, if you consider the image is a collection of pixels, right? It's a placement of pixels. And every pixel is in case of the grayscale, every pixel is a value varied from 0 to 250. And if it is a color, then it's a combination of 3 different colors, right? That's RGB, where every color is again ranges from 0 to 255. So in case of the color, every pixel is a tuple of 3 values. And it's a grayscale means it's a single value. Every pixel indicates a value ranging from 0 to 255. And what this thresholding does, so if you would like to apply the thresholding operation on an image, maybe you can set the threshold value as something like P. And the intensities or the pixel values which are above this threshold, so will be set to 0, and which are above this threshold will be set to 1, and which are below this threshold to 0. This is how we can convert the grayscale image into the binary image, and that is what the thresholding of the image is. So basically, you can observe here, this is the grayscale image, and after applying the binary threshold, can you see, after applying the binary threshold, so your image, rather than having a gray color, it became the like 0, 1, only these 2 values, right? This is how you can convert that into the binary. And inverse binary also you can see. So what is this inverse binary? Here, binary means, so above the threshold value that is converted to white, and below the threshold value it is converted to dark, that is 0, right? That's 0, 1. And now inverse binary means whatever pixel is 0 value here, that becomes 1 here. So the reverse operation, 0 becomes 1 here, 1 becomes 0 here. So that's the difference between binary and the inverse binary. And how do we apply this thresholding operation is, we can use the method, yeah. So in OpenCV we have threshold method. So this is a method. You can pass your image and like what are the threshold values. So like 127, and you can have the lower threshold and higher threshold also. So the both thresholds also you can set. So this is how you can apply the thresholding operation from the image. And then you can apply, we are now going to discuss about the edge detection. Okay. So how to detect the edges? So what are the, what is edge basically? So edges are the surroundings of the object, right? So you can use it in compression also. So I don't want to send the image in its original quality, in the reduced quality, or the compressed size. I would like to send the image, but still I would like to have some details on it. So then I can apply the edge detection, and then I can compress it, and then that's one way of looking at it. Or otherwise, I would like to see the object details of it. So in the image processing point of view. So in that case, we can apply the edge detection. So why edges are so important? They allow you to get the details of the image. So when you look at the original image, you will not be able to see this original image. Let's see where the pictures. Okay, whatever. That's a on the digital image processing book also we have this image, right? The cap, the lady wearing a hat. So that same image is there. So to get the outline of that objects or to go into the details of the objects, the edges will be identified. And to get the edges, we have the edge detection methods. We have something like Sobel edge detection. So all these edge detection methods we can apply. And how do we get these edges is what happens. So typically what happens in an edge detection algorithm is more or less, so take consider this as an image because it's a 4x4 image. These are all the pixel values. And this 4x4 image, 4x4 size image, the edge detection algorithm, if you ask what happens is every neighboring pixel, it looks for a change. What is the change between these two pixels? And what is the change between these two? Difference between these two? Difference between these two? Like these two. It's like every neighboring pixel, it looks for the difference. And if the difference is going beyond the threshold, if you observe that, the difference between these two pixel values is only 1. And these two is like 3. Right? And these two is only 1. And these two is only 1. Right? But these two, it's like something like 70 or so. So it's large. So whenever the change between the pixel value, neighboring pixels is too large or above threshold, then it will be, marking that as an edge. You see that? It's an edge. In this 4x4, you can see. So in the first row, if you observe, this is the edge. And in second row, again, you can see this is here is the edge. Right? And here also, you can see. From the first row to second row in the neighboring. For every neighboring, up and down, every neighbor, right? So that is how you get this kind of, can you see? So this part is detected as an edge. So this is how an edge detection algorithm basically works. Yeah, for the details, maybe you can go through it. These are all the stages because we are running out of time. So these are all the typical stages of an edge detection algorithm. It does the noise reduction first, then the gradient calculation, then the non-maximum suppression, then apply to threshold, like higher threshold and lower threshold, and which are in between them, then only it will consider as an edge, otherwise it will be ignoring it. And then like connecting the weak edges and the stronger edges it does. And then finally it will be displaying the binary image. So that is how it is. So now let's see. This is the original image, and on this image, this is the, you can observe these are the edges. Okay, and how do we apply this? So here you can see we are applying the canny edge detection, or you can apply the Sobel edge detection, or any kind of edge detection algorithm you can apply. Just showing you like how to apply the canny edge detection. CV2.canny is the method you can apply. You just pass the image color, and what is the threshold that you would like to use? You can pass this lower threshold and the higher threshold. Like you can again vary it and see like different impacts, and whichever is giving you suitable for your data that you can use. Then how to extract the features from the image. So the next concept is extracting the features. So features basically are like the key points. So I will not be going much details into this also because I would like to focus more onto the applications. I will just give you an overview of like because even if I go into the details also, I cannot give you the complete details of it because that itself will take another session. And these days we are not looking at these kind of feature detection also. But for these applications, it will be useful. That's why I'm going to. Yeah. So now, what are the key points? So the key points are the identifiable points, like corners or edges or the regions, which are having the unique texture and all, which are distinct in the image. So those are the key points in an image. Right? And they will be, these key points are the ones which will be helpful for, the transformation, transforming the image, like rotation, scaling, translation. When you are applying all these, you can use these key points. Like you don't want these key points to be changed. So that is where these key point extraction algorithms will be useful. And there are different techniques for the key point extraction, like Harris corner detection you can use, or SIFT. So SIFT stands for scale invariant feature transfer. Those who are dealing with the digital image processing or the computer vision like traditional computer vision algorithms, the feature extraction techniques you can see. The SIFT, scale invariant feature transform, or like SERP, you can use speeded up robust features you can use, or the ORB you can use, oriented fast operated. So these are all the different techniques, or you can use fast. So these are all different techniques that can be used for the feature key point extraction, basically. And where you can use it is, you can use it for image matching or the panorama stitching you can use. We'll see these two applications today. And maybe tracking and all tomorrow we'll see. So I'll show you at least one of the feature extraction technique, how to implement that in OpenCV. So we will be seeing how we can extract SIFT feature extraction, like scale invariant feature transfer. So why is it named as scale invariant feature transfer? Even if you change the scale of the image, I have shown you the scaling. What is scaling in image? Here you can see different size difference. So here size is large, size is small, right? Whatever the same, even if the same figure also we can represent like very large in size. Yeah, the same person, you can, if you take it from close, it will be like very huge in size, right? From long distance, it looks like a small person. So though there is difference in scaling, the features will not be changed. So such kind of features, that such kind of feature transformation we will be getting using, sorry, the features which are not invariant, not very varying to the scale, or which are what do you say, which are very much robust to the scaling. That is a better way of putting it. So that is what the SIFT features are. So now we are going to see how we can extract those kind of, yeah. So once we extract them, it looks something like these are all the key features from this image. And how do we get that? So again, from the very beginning, I am showing it. So you read the image, then you call once you load the image, and then you, like when you are applying any of the approaches, you better load the image in the grayscale. And now we are calling the SIFT.create. Okay. So SIFT.create is the method that we are using to get all the key features. And then you have to call the SIFT.detect and compute on the image. So now you will be getting all the key points and the descriptors. Okay. Now once you get the key points and the descriptors, then you can place all these key points on the image. So you can place them on the key points on the image. So you can call the draw key points method. And you already got the key points and descriptors from here. And you can pass all the key points to this, so that you will be getting the key points overlaid on the original image. This is how we can get the key points along with the image. Okay. So this is how the SIFT key features can be extracted. And similarly, the ORB features. So ORB stands for oriented, fast, and rotated. That's the full form of it. And I'm not going into the algorithmic point of view because it takes a long time. It is sufficient for you to understand how it can be done. So then ORB_create method you can use to extract the ORB features, key points, and then similar to the earlier things, like you can call the detect and compute by passing the image as an argument. You can get the key and descriptors, and you pass the key pointers to the draw key points method. All the rest are the same. So we are overlaying the key points on the original image. This is how we get it. Here you can see you will be getting better key points when you are using the SIFT, right? Yeah, and here like large key points basically when you are using the SIFT. And in case of the ORB, so oriented, fast, and rotated, right? So this here is pointing to only the sharp features, not the other unnecessary details. And you can see where to use what. So when to use what kind of feature extraction technique, because ORB is like very good, right? Yeah. So for the real-time processing, if you would like to do, then you can see ORB or fast you can use. Either of these two feature extraction techniques you can use. If you would like to see high precision, then you can go for SIFT or SUF you can use. And basic detection, you can use Harris Cortland detector you can use. And you can use like the ORB is a patent free and open source. So if you would like to go for any open source algorithm for feature extraction, you can go for the ORB. So that is how when to use which kind of algorithm, this is justification. And you can see the differences. I'm not going to explain because we have already seen that. You can see ORB and yeah. So ORB, yeah, template matching basically. So this is the original image and this is the, can you see? It's rotated image, right? And from both the images, we extracted the key points and then we are matching them. So that is what the template matching I was talking about. So this is what the template matching we are doing here. So this is the original image. Can you see? And on this image, we have identified all the key features. And on the rotated images also, we identified the key features. And we are aligning, right? Key points here and key points here, we are matching it. So this is what the ORB based key point extraction and the matching. And now, so for SIFT, you can see. So SIFT, this is the original image and this is the rotated image. And the key points were identified on both the images and then they were matched. So this is how you can get the understanding. So which algorithm is doing better. And SIFT gives you a lot of lot of key points. And ORP gives a faster version of it. So not too many key features, but it gives you better reasonable accuracy with quick processing. So that's where, depending on the application you're using, you can take a trade-off between whether to use ORB or SIFT, key point extraction. So now let's see where you can use these key features like the feature extraction techniques and some real-time applications of the computer vision using OpenCV. Let's have a look. Right? I would like to first explain about the panorama stitching and then the face detection algorithm. Okay. And now panorama stitching. What is panorama stitching? So this is useful. Maybe if I explain this, we can better understand with the images you can see. So when we are taking the photographs, so maybe using a single shot, we cannot, you cannot get the entire visual of it. Then what we do, we take different images, right? This part as one image, this part as another image. And these two together, we can get a single image. Can you see? It's actually a single, these two are belong to single scenery. And in your mobile phones also, we have such kind of feature basically nowadays. So you can try it out. So now these two images, we are stitching together and getting a single image as if we are taking as an original image itself. Can you see that effect? So this kind of approach, we call it as panorama stitching. And of course, here only two, it can be extended to any number of images. So here, these are all the belonging to like different parts of a scene. And then all these together are stitched together to get this kind of visual appearance. You see that how beautifully it is doing. And this approach, this concept, we call it as panorama stitching. So what is this panorama stitching? It is a process of combining multiple images and how it is doing that. Is it just like side by side displacing? It's not like that. So overlapped part, it will be removing, it will be trimming away, and then the unoverlapped part, it will be connecting together. So definitely there should be some overlap in the images, then only it can stitch, otherwise it cannot stitch. Please understand that. So that is what the panorama stitching is. And of course, it's commonly used in photography to capture scenes that cannot be captured in a single shot. So in our mobile phones also nowadays we have that feature. You can try it out. And now let's see. So what are the different stages of panorama stitching? First of all, we need to extract the features, like key feature extraction, key point extraction we have seen, right? So we can do that, and then we do the matching of that. So I have all, that's why I have shown you actually. So the matching and all. So here this is the image and this is the image, and from both the images we are identifying the key features. So there will be definitely some overlap, common key points, right? Yeah. So based on that only it will be doing the stitching. So you detect the features and you do the matching. So how we can do that? So you can apply either of the feature extraction technique, the key point extraction technique that we had discussed earlier, and then you match the key points between the adjacent images. Then you estimate the homography of it. So what is that? So you need to here, if you observe that, so though it is in different scale, it should be, we are going to stitch these two together. Then how can I do that? So based on the key point, in which kind of transformation I can apply the, matching. So that is what will be decided. That is what the homography estimations. Find the transformation that maps a point in one image corresponding to the other image. So that is called as a homography estimation. So once the homography estimation is done, then it will be doing the transformation in the required homography. Okay, and then image blending. So you combine these two regions, like the overlap regions, you trim that up and then connect them together so that you will be getting a single blended image. So these are the different stages of the panorama stitching. So now let's see how we can do that. So maybe I will show you one example. Yeah, here you can see. So these are the photographs of IIT Madras a couple of years ago when I was there. Yeah, you can see this is one image and this other image. These two images, and then we are connecting it together so that it's a stitch. Can you see? Well, there is some overlap, right? It's part of the tree, you can see. So now this is a stitched image. Now, how we are doing it? So we are loading it. I have already shown, right, how to load the image and all. So we are just loading it. And, hello? Is there any? Okay. So now let's see. We are just loading the image, the color images, like left side image. I'm calling the first image as left and this right image as right, just for the sake of convenience. We just load these images and then resize the images into whatever the size that is required, like same size. And then we change the color to the, actually it is BGR. So I would like to convert that to the RGB color to it. So now both the images are changed into the color schemes also. Now you can see I'm just displaying it here. This code is just to display using subplot, that's nothing about that. I'm just displaying it. Then after that, you can see images dot append of left. So I am creating a list of the images. Here I'm stitching only 2 images. Even if you have 10 images also, you can take all the 10 different points of that. You can try it out now itself. So you can create a list of the images, and that's what I'm doing here. So images is an empty list. I'm attaching all the images that I have. I have 2 images. I'm attaching that to this list. So once we have that, so we can do the stitcher dot create. So a stitcher of panorama stitcher object we are creating. So is it stitcher dot create? So then you stitch the images. So stitcher dot stitch of images. All the images that we tagged into a list, right? So that list you call with stitch. That's it. It's a very simple straightforward. So then you will be getting a panel, so like panorama image. So then once you get the panorama, you try to display it. So whether the panorama image is like, actually it is. So you check it whether it is done properly or not. So when it is correctly done, then RET will be getting a true value. Otherwise, it will be getting a false value. So you check that and then you display the image. This is what the panorama image is. And you can try it basically with multiple images also. Here I have shown you only with 2 images. You can try with the hundreds of images also, or tens, at least tens of images. And then the next kind of application we would like to discuss is the face and eye detection using the AICTE. So the next one, I'll show you what we are going to see now. It's only 10 minutes, right? Yeah. So this is the original image, and this is the face detected image. Can you see that? And this is only the face detection. And then here you can see the eye detection. Eye regions alone are detected. And basically the detectors I'm overlaying on the original image. That's how we are getting it. And here also. And both are face and eye together. And this is from an image which contains one single face. And we can have the image like from multiple faces, the image with multiple faces. And how do we detect that? So that's what we are going to see. How far we can do. Let's see. We have only 10 minutes, right? Yeah, how to detect the face, and for this we can use like OpenCV supports a lot of different functions. The our cascade classifier it can do. And for this, we have to, we have to have an XML file. I have this XML file. Yeah, this is what for extracting the I region alone, you need this XML, i.xml, and frontal face. This is the XML file you need, and these are the XML files that we need to use for this. So cascade classifier is the method of OpenCV, and for this you have to pass cv2.data.havecascades. So this is what you need to pass plus your XML file. So XML file, this is having actually the code related to the face detection. If it is frontal face, then the face detection is there. And if it is the eye region detection, then you have to pass a corresponding XML file. So once you do that, your face cascade object will be created. And here we are loading the image. Here you can see I'm reading the image of the face.jpg, and this is the face.jpg image. And just loading it, and I'm converting that to the BGR to RGB so that I can process it. Then this is the input image. And you can convert to gray color also. Like I get different color codes, different color codes I have done. And then you calculate the coordinates of the bounding boxes. So how you can do the bounding boxes calculation is, so detect multi-scale. So you already have applied the hard cascade. And the hard cascade, when you call the detect multi-scale, so then you will be getting the face detection. So the gray, after converting the image into grayscale, you call this detect multi-scale method, so that your faces object, that region will be detected. Then if you have multiple faces, it will be giving you a list, and it is only one face, because I know that, I'm sure that it's having only one face. It's like faces of 0 and 2. And I'll be getting the starting position of this is the XY region of the face detected region, and this is the width and height. So how much width and how much height is what we get. Right? And we are going to overlay this that region size. And what is overlaying means, here I'm just drawing a rectangle on top of this, whose starting position is X and Y, this at this location. I already knew that from the region XY, with the width and height, with this width and height, there is a face region that is being detected. And how can I visually show that? I am drawing a rectangle on top of this. And with what sizes I can draw the rectangle? So if I do draw the image, you overlay the rectangle with the sizes X, Y, and X plus W and Y plus W. So that's how you will be getting this rectangle, like the detected face visually marked with a bounding box. Can you see that? Yeah, this is how you can detect the faces. Now, rather than finding the face alone, I would like to find the eyes. Okay, and here, like maybe if you would like to see both also, you can do. First, let's see how we can do the faces, like eyes, eye region. Now, earlier I have shown you how to use a cascade classifier to detect the faces. And now to get the eye region, you have to use this XML file and then get the eye cascade out. Once you get the eye cascade of the loading of the image, I'm not showing you because we have already seen. And you call the multi scale of gray. And what is this eye cascade? Eye cascade, yeah. What is eye cascade? Yeah, here. So you see, eye cascade dot detect multi scale of ROI region. That ROI region, so you get the eye cascade. You please try to understand. Once you detect the first you apply the face detection, and in that region only you apply the eye region. Otherwise, we are very sure that eyes will be part of the face only, right? Eyes will not be somewhere else. If you apply the eye detection, eye cascade algorithm, like hard cascade to detect the eyes, it will be detecting non-eyes also as eyes. To avoid that problem, to reduce that risk to maximum extent, what we can do is, so I have done this in a better way. So what I have done, I have first identified the faces, and in that region I have applied the eye detection, so that my eyes will be detected only in the face regions. so that the false alarm will be less. Okay, the false positives will be less. Now let's see, once you get this eyes, then you overlay it like there are two eyes, right? So eyes of 0 and eyes of 1. That is one. In case of face, only one face will come. In your eyes of 0 and eyes of 1, both you draw the rectangles on the face image. That is how you get it. And the same way, like anyhow here we detected faces also, and face also and eyes also. Both can be overlaid. So when you are drawing the boxes, you just draw the rectangle for the face and rectangles for the eyes as well. That's it. Like it's self-explanatory. You can understand it. And now we are going to apply it on multiple faces. What we have done here, when you apply the detection, yeah. So here face cascade dot multi-scale detect. Here it will be returning faces, and you were sure that this image is having only one face. So you are applying the you are taking only faces of 0, right? Now, if there are multiple faces, what happens? This faces should contain multiple a list of x y coordinates, y w h all these values, right? So it's a list of tuples where every element in this list contains xy region, that is the starting point of the face and the width and height of the faces. Now, rather than taking the faces of 0, what we do the like for loop, we iterate over that, and then we get all the faces. That's it. Now, look at this image. On this image, I'm going to apply the hot cascade for facial region detection. So you are going to call the frontal face default.xml because I would like to apply the face region detection. And my input image is multi-faces, and I have loaded it, converted into gray. And then I call the face cascade dot detect multi-scale. So multiple images, if there are multiple facial regions are identified, that will be returned as a list. Now, for every face that is found in this, you are going to extract those regions and then you are going to get it. And not only that, I'm getting the eyes of it also. So again, in that every detected region of the face, I'm calling the eye detector. So then we are overlaying it. So that's how we get the eye regions and the face regions for every face that is part of this image. Okay. Yeah. So it's exactly 7:30 now. So I could manage the time very well. Maybe a couple of minutes are left. I can take questions if there are any. Hello?
Hello.
Yeah.
Madam, your session is over.
Yeah.
Okay. So participant, if any question, you can ask the question to the experts. Any participants have any questions?
No questions? Yeah, thank you. Nikhil.
Okay. I think there is no question, madam.
Yeah, thanks, sir. There were few
So thank you, madam.
during this session. So during the session, there were few. So it was
Okay. So thank you, madam, for your excellent lectures. So we conclude the session 3 here. So thank you, madam.
thank you. I thank the organizers for giving me the opportunity, and I thank all the participants for the patient listening. Thank you. Thank you very much.
Okay. Thank you, madam. So within very shortly, we start the next session. Sir, any feedback? So,
Good evening, sir. Am I audible?
yes, sir, you are audible. So, in the session 4, our expert speaker is Dr. Gaurav Kumar. So, please, sir, you start your session.
Okay, thank you, sir. Good evening to all the participants. We are starting this session. Dear all, I have shared my screen. Kindly confirm whether screen is visible and you are getting audio clearly. Kindly confirm whether screen is visible and you are getting audio clearly.
Yes, sir, screen is visible.
Okay. So, dear all, in this session, we will discuss about one of the very important implementation in AI, that is deployment of machine learning and deep learning models on cloud. You might have seen that generally computer vision based applications, speech recognition, or we are working on NLP based implementations. These are deployed on console or some specific platforms like integration of TensorFlow with some front end, and desktop applications are created. In this session, our focus will be how to deploy the machine learning and deep learning applications on cloud, on web browser. Whatever application you are running, whether it is a pre-trained model or self-created model, custom model, how to deploy it on web browser. In this particular session, I am not using any PPT. I'm not showing any presentation. Everything will be in live demonstration mode. I will show you with different libraries. 4 to 5 libraries I will try to cover depending upon availability of the time, and with live demo. Whatever application you are already having related to machine learning, deep learning, generative AI, how to deploy it on web browser. Because many times, or in almost every instance, we have to work on presentation part also, how to present your work. For this, we will use some free and open source libraries. Along with that, we will see some free clouds, some freemium clouds. So as you can see, I'm showing some screens here, some websites. Streamlit, very popular library for development and deployment of machine learning, data-based applications, computer vision-based applications on cloud, on web browser. Generally, we see applications in this way. For example, in yesterday's session, we have seen like whatever application we want to run, it is executed on Google Colab. Okay, Google Colab is fine. But if I want to give that particular application a look of web-based application, a look of a website, for example, this code, okay, for example, this particular RAG code, some particular clip-based code, I want to use a specific HTML page. I want to integrate it with HTML page with some web-based application so that there will be a browse button. Okay, there will be no Google Colab. I want to use my own custom platform. For that, we will use some libraries. One of the very popular, very prominent library is Gradio. Okay, in very less lines of code, we can give our application an interface of web GUI. For example, in this way. Okay, so simply we will be able to click on some particular buttons. We want to generate some images. If we want to match some biometric medical images, that can also be done. If we want to create a chat bot similar to chat GPT, Gemini, that can also be done. Okay, so we will see its playground is also available. If you want to integrate it with Google Colab and other platforms, that can also be done. Okay, so in this particular session, 4 to 5 different libraries we will use. Very first library we are covering today, that is Gradio. Okay, after that we will come to Hugging Face spaces, and then we will go to render railway. So first of all, I'm showing you which platforms we will cover. Render, railway, that is also cloud for deployment of machine learning and deep learning based projects. Okay, you can deploy, you can link it with your GitHub repository. Okay, no need to install TensorFlow in your laptop locally. If you want to work with vector databases on cloud, everything will be on cloud. Railway is there. You can work on render. Fastest path to production. Whatever application you are already having, for example, satellite images, you want to integrate it with computer vision based applications, you want to fetch some features, and everything should be on cloud. Okay, so we can use these platforms. Render. Now we are starting the demonstration part. Okay. Very first segment, very first implementation we are covering related to integration of Gradio with Google Colab. Okay, is this screen visible to all participants? Is this Colab notebook visible to all? Kindly confirm.
Yes, sir.
Okay, so one by one we will see. I will start from machine learning. Okay, first of all we will see how to create web-based application from our machine learning based implementation. Okay, then we will move to deep learning, computer vision. Okay, one by one, so that from scratch, from very beginning, we will be comfortable. So this one you can see, pip install as scikit-learn. We are using Gradio. We can install, and this particular implementation, it is related to random forest classifier. Okay, it may be anything. It may be artificial neural network. It may be your support vector classifier, random forest classifier, whatever application you want to develop. Okay, our major work, our major motive is to give this application a GUI look. If I execute this code, this highlighted code independently, then obviously we will get the output, no problem. But that particular output will be on screen. If I execute only this part, okay, this particular part, in that case, we will get output on Google Colab. That is fine. I want to convert it, we want to transform it in form of a web-based application without manual coding in PHP, .NET or Java, JSP. Within Python, we have a library that is known as Gradio. We have installed, you can see that. And now we will integrate it with Gradio interface. You can see that this is iFace. iFace is equal to GR. What is GR? this Gradio we have integrated, and you can see this is interface, which what is input level. So uh, which particular text boxes we want to create, whether we want to create radio buttons. So you can see that this particular iris detection, iris based classification is very popular problem in machine learning, very popular implementation. Okay, so we are giving this particular implementation a look of GUI interface. Okay, now iFace.launch. So as soon as we will execute it, only this part, only these these 3 to 4 lines we will add, you will see a graphical user interface will be generated along with a live URL. Okay, first of all, I'm showing you this part. After that, I will show how to integrate it with with your pre-trained model, deep learning, or whatever it is. So this one. So on click of this, you can see now it is working on cloud. Now it is live URL. And obviously it looks more professional rather than we are giving input within Google Colab, for example. So just randomly I'm giving some values. Okay. This one, submit. Now you can see this one, this is the output. If I'm changing it, for example, just randomly I'm giving some inputs. Now submit this one. Okay. So whatever input you want to place, okay, so in form of a web-based GUI. Now it is CTOSA. So if we want to present our work in this particular format, it will be more effective and more professional. Rather than this particular part within this particular screen within Google Colab, and then we are sharing. For example, I want to share my implementation to my guide or to one of my research mate. Okay, then this option is very effective. Why this option is effective? First of all, your source code will be private. Your source code will not be shared. If I share this particular notebook to my classmates or teammates, in that case, definitely this source code will be out. But if I'm giving them only this particular URL, in form of a web-based application, in that case, they will be able to access only the implementation part, only that execution part, rather than backend source code. Okay. But if I'm sharing this particular notebook, this URL, in that case, everybody knows that source code will be out and it can be misused. So that is one part. Second part is it looks better. This interface looks more professional. Gradio, with Gradio. So to any application, you can create this interface. Its output, its interface will be visible within Colab, or you can generate its live link. You can see that its public link is generated. By which command, by which syntax this public link is generated, we have given here. You can see that share is equal to true. Gradio interface with share is equal to true. Public link is generated automatically. Okay, is this clear to all of you? Are you getting this point? Only this part. Okay, no need to understand it with too much complexity. Only this part, very small implementation. Okay, just using a random forest classifier and giving it a graphical user interface with Gradio with these 2 to 3 lines of code. Okay, now second implementation. This is first part. Now second part. Now I will come to that particular part related to classification problem. Again, we are taking a different classification problem, but on different data set. Now we are getting this particular data set. Okay, on this specific data set that is associated to GitHub account. Okay, this particular data I want to train. It is a CSV based data set. Okay, this specific data I want to train, but I don't want to get results. I don't want to present my results within Google Colab or on console or on command prompt. I don't want to use any command prompt. I want to use a graphical user interface. For that, you can see that everything will be same. No big change. Only 2 to 3 lines will be added in your code. First line will be added, this one, import Gradio as GR. This is the website. So previously also I have shown you, this is the website, Gradio. It is free and open source available, okay, freely. And lots of companies, lots of corporate giants are using Amazon, Facebook, okay, you can see that Siemens, so many corporate, because most of the corporate applications are in form of web-based application or in form of Android or iPhone or smartphone based application rather than this interface. Okay, so code will be same, internal code will be same. We are not changing inside any particular code. If I execute this code without Gradio, in that case output will be on Google Colab or on command prompt, whatever tool you are using, okay, whatever interface you are using. But we want to use it, we want to present the output in Gradio interface. So you can see that in Gradio, what we are giving drop down menu, this drop down passenger class. So from this particular data set, we are already aware that this specific data set, we want to use some drop down menu. For example, this particular passenger ID, okay, or survived. So we know if we are aware that this particular value is in range 0 to 5. So what we can do, we can give a drop down menu. Okay, for gender, we can give a radio button. Okay, so what we will do, so this code will be same, and labels, we will put this drop down for whatever inputs we want to use. Okay, this one drop down for male, female, label is gender. For age, we are using a text box number. Okay, and now if I execute it, only this 2 lines of code, only this one, this particular part, we are adding at last of your code. Automatically a live URL will be generated, and this particular live URL I will click, and now it is on cloud. I'm sharing same live URL in chat window. So click on this link and confirm whether it is opening in same way or not. Click on this link and confirm whether you are able to see this output as web-based application or not. Click on this link and confirm. Are you getting this interface? In chat window I have given. Okay, so you can see that how much it is easy. For example, I want to show you my research work. I want to show my output to some journal. I want to, for example, some specific to some specific teammate, we want to show some results. So you can see that this one, gender, this, okay, age, for example, this, submit. So you can see that how much it is easy. Male. So you can see that this one. Okay. So whether it is a CSV data, so up to now we have taken CSV data. Okay, this one is CSV Titanic data, very popular benchmark data. When we work with deep learning based applications, machine learning based applications, generally we work with benchmark data sets. This is one of the very popular benchmark data. Okay, lots of data sets, sources available. One of the very popular source of data set is IEEE data port. For example, you are working on some research domain and you need a specific data set. So this one is very popular source. Okay, you need some data sets related to computer vision, you need data sets related to some specific satellite images, okay, medical images. So all of these data sets available here. If you are working on some forensic application like malware detection, virus detection, malware analysis, so all of these data sets available here in free distribution. Okay, so that's why you might have seen in most of the academic research work, we take benchmark data. So iris data set, that is also benchmark data. Titanic data, that is also benchmark. ImageNet, COCO data set in deep learning, these are also under benchmark category. These are pre-tested. Okay. Now we will see some other parts. Up to this point, is it clear to all of you? Up to this point, is it clear to all participants? And kindly confirm so that we can move ahead with our next part related to computer vision, deep learning. Okay, so I will share this particular code, this notebook. So what you have to do, you have to integrate this particular segment at end of your code, at end of your machine learning or deep learning code. Okay. Now we will see some implementations related to computer vision. Okay, I'm coming to next part. In previous session, yesterday's session, we have discussed about pre-trained models. Previously, we have seen output of pre-trained model on screen on Google Colab. I don't want to use output on Google Colab. We want to use a cloud. We want to give it graphical user interface. You can see that this code is the same. This is same code. ResNet 18, ResNet 60, ResNet 50, whatever we are taking, PyTorch code. This one is, you can see that ImageNet classes. Okay. So in previous session also we have seen we are taking ImageNet dataset. At end, you can see that what we are doing, only this code is added. Everything will be same. All other source codes will be same, all other scripts will be same. At end, we will integrate this specific Gradio segment. And now you will see what will be the interface. Okay, so iface.launch and share is equal to true so that we can get a public URL, open URL on click of which we will be able to browse some images. So you can see it is downloading that specific. Okay, now it is this public URL is available, and now it is on web browser. Separate implementation. No need to share your notebook. No need to share your source code. Okay, this is ResNet image classifier. Drop image, so you can see how much it is professional. Okay, so click on which image I want to browse. I want to check this image, submit, and you can see that this is the output. In same way, for example, any other image we want to see, some specific image we want to predict. For example, this image I want to take. Okay, in my implementation, I want to check, I want to test whether it is giving correct results or not with ResNet image classifier. But we are not checking the output in Google Colab. We are checking it on Gradio Live Cloud. Okay, so you can see on click of this, I'm uploading new image, submit. Now you can see predicted class fox squirrel. So it looks more professional. And second part that we have discussed, that no need to share your complete notebook. You want to you want to present your execution, you want to present your research work, in form of a web page, in form of a URL, you can share, and other teammates will be able to check the output, okay, whether this output is fine or not, or which type of output should be there, rather than giving your complete notebook. Otherwise, if you will give your complete notebook, anybody will be able to modify your source code. Okay, anybody will be able to generate a new source code from existing source code by minor modifications. Okay, so till your work is finished, you have to keep your code, you have to keep your execution secured and private. And it is possible only if we are using such type of implementations. So you can use this particular part. So I will share this particular implementation, this specific implementation to all of you, this specific source notebook at end of this session. Is this clear to all of you up to this point? Kindly confirm.
Yes, sir.
And how much it is looking difficult? Is it understandable to all of you? Kindly confirm. Are you understanding what I mean to cover and what I'm showing here? Is this clear to all participants?
To me.
Yes. Okay. Now, dear participants, we are coming from. Any question? Any query?
Yes, sir.
Okay. Sir, is it possible that all queries we can take at end of the session? In last 15 to 20 minutes, we will discuss each and every point. You can note down your queries.
Okay, sir. Note down of everything. I
fine,
can
sir?
note down, but I am fine. I can note down, but some voice is important. But everything should not be taken as a note down as the writings. Sir, your voice is important.
Okay. Please ask your query.
Sir, if the command line work is important, what is the operating system, the Windows or Linux, or for the deployment matters?
For this type of implementation, are you asking about the operating system platform?
Yes.
Okay, no, it is platform independent. Anywhere you will be able to deploy it. Okay, whether you are using Linux or Windows or any, so anywhere you will be able to install on any platform, you will be able to deploy, even on command prompt also. For example, you are integrating on a local TensorFlow. In that case also it will work.
Sir, in command prompts, as you do super user, but it does not work in Windows.
No, it will work. You can try. It will work. It is openly available, free and open source. Without any restriction, it will work. And if you face any specific problem, you can mail me. After this session, I will see those screenshots or those implementations on which you are working.
Sorry, sir, to disturb you for this lecture.
No, sir, it's fine. You are welcome. Is this clear to all of you up to this point? Can they confirm? Other participants, is this clear?
Yes, sir. Yes, sir. Yes, sir.
Okay, now dear participants, we are coming to our next platform, very important platform for deployment of deep learning based applications, machine learning based applications. Yes, in previous session also we have covered it. Hugging Face. Hugging Face provides you free cloud to deploy your machine learning and deep learning based implementations. So one format we have seen just now with Google Colab, and it's linking with Gradio. Gradio will give live URL and you will be able to share it. That is fine. If I want to make my implementation, if I want to deploy my model in permanent format, permanently on some platform. Permanently means till I delete. In case of Google Colab Notebook, you might have seen that after some particular time we have to reconnect. Okay, there are certain services which restart automatically. I don't want to use that particular platform. I want to make my implementation permanently available on some cloud. For that, we will use Hugging Face Spaces, this option. So I'm highlighting this part. Hugging Face Spaces for deployment of AI-based models on cloud. It is completely free. So I will click here, Spaces. Okay, this one. Hugging Face Spaces. This is, you can see that it is visible here. Spaces, the AI app directory. So what you have to do, simply create your account on Google, on Hugging Face. Okay, and you can see that 100 GB quota is available. 100 GB is more than sufficient. If we are working on some implementation, then you might have seen that this much space is not required. 100 GB. They are giving us free quota, this one. Now I want to deploy some model. Which model? First of all, I will show you the code. I will show source code. Which model I want to use? This one. I want to work on this one, this particular Python code. It is related to SqueezeNet, computer vision based application for image classification using SqueezeNet. So you can use ResNet, you can use ALXNet. So for this demonstration, I have taken SqueezeNet. Okay, it is also a pre-trained model. Models is equal to SqueezeNet. You can write here ResNet, ALXNet, GoogleNet, or ChecksNet from model zoo or any other. You will be able to take. ImageNet we are taking. Okay, this code may be any. It may be this particular specific code, maybe any script, not only pre-trained model. It can be anything. For example, you are working on medical image analysis, you are working on satellite data analysis, whatever you are doing, simply take this source code here. And at end, in same way, we put Gradio code, Gradio script, Gradio interface. You can see that this is same script, this is same format we have seen in case of Google Colab. Now I want to deploy this particular code, this deep learning code, computer vision code on live cloud that is permanently available, 24/7 available. No need to restart anything, it will be available. So we will have, what is the convention? First of all, we have to create its file app.py. This is my app. Okay, app.py file we will create, in which code will be available. Second file we have to create requirements.txt file. In this, we will have to give those libraries which are required to run this code. I'm repeating this point. Whatever code you are having, this is your script, this is your machine learning or deep learning code. Okay, to run this code, which libraries we need? Gradio, Torch, Pillow. Gradio, Torch, Pillow. So two files we will have to create. app.py, requirements.txt file. We will have to upload these files on Hugging Face, new space. First of all, I'm creating new space on this cloud. New space, pre-trained model. Okay, or I'm giving here SqueezeNet. Okay, create a new space. Okay, I'm giving here license. It is open source license. Generally, we give Apache. For such type of implementations, we give Apache license for open source scripts. You can use MIT also, OpenRail. So I'm using Apache license. Which GUI we are using? Gradio, CPU. Okay, and I want to deploy it on public cloud. Public, create space. Now you can see that it is available. Now this one, you will get. Okay. Now you have two options to upload your source code. I want to upload this particular source code on my space, on my cloud space. One is I will link with my GitHub repository. These are the commands. If you are aware with GitHub, so git add app.py. So this is one option with your Git. Otherwise, simply come to files here. This one, files. Come here. Click on this particular link. This is the easiest way. If you don't want to work with GitHub, don't want to clone anything, okay, you don't want to commit anything, simply on web browser I want to work. Files. Click on files, contribute, upload files. Simply we are uploading the files, deep learning files or codes which we want to work. This is my Python code, deep learning code. Change, commit changes. App.py is uploaded. One more file, upload files. Second file I'm uploading requirements.txt file, because to run this file, to run this Python code, deep learning code, I need which specific packages, requirements.txt. Two files I have uploaded. After uploading these two files on Hugging Face Cloud, what I will do, I will simply click here on name of my app, name of my web app, click. Everything will be executed on cloud. No need to download anything, no need to install anything on your laptop. Okay, no need to install TensorFlow. Everything will be on cloud. Now you can see that whatever application we need, whatever code we are having, this specific source code, now it will be loaded on cloud, okay, on Hugging Face Cloud. Okay, and finally it will give us the graphical user interface, and that URL we will be able to share without sharing your source code. No need to share your notebook, no need to give anybody your code. Simply upload on cloud, generate its URL, it will be permanent. So you can see that all packages will be installed one by one. Whatever packages are required to run this application, whether it is a machine learning application or deep learning application or generative AI based application, whatever it is. Okay, it takes 1 to 2 minutes, and after that it gets installed. Okay, so you can see that it is getting installed, and so what it is doing, it is downloading the packages, which packages are required to execute this particular code. Now very soon we will see that it is done. So pushing image and building, you can see that. Is this process visible to all participants? Kindly confirm. Very simple. We are working on cloud, not on local system. Everything is on cloud. Okay, you can give data from Amazon also, no problem. Okay, but actually in Amazon, what is the major issue? You might have seen that even free tier of Amazon, in free tier of Amazon, we have to link our credit card or debit card. In Hugging Face, no need to link your credit card. Okay, I am not using any paid account of Hugging Face. It is free account. Okay, no need to link your payment gateway. No need to link your payment details. In Amazon, in and Microsoft Azure, GCP, other cloud, you might have seen that even for free tier, we have to link our card details. And many times it happens that we forget that some instances are open. And when people come to know, when they have bill of $2,000, $5,000, because many times we have seen such instances, such things that people start some instances on Google, on Amazon or Azure, and they forget closing or deactivating those instances. And at backend, billing is done. Okay, billing keeps on. So that becomes very problematic many times. So rather than taking that cloud in which some payment details to be mentioned or card details to be given, simply take very classical cloud. Okay, in Hugging Face, no need to give your payment details. Everything will be on in free distribution. Okay, so it is building and now it is running. Here now you can see that it is my space. Now this is lightweight image classifier. Okay, so if I want to show this implementation to somebody, to some client, to my guide, to my teammates, to my classmates, so simply copy this URL and I will send it by WhatsApp or whatever it is. Okay, and and that particular person will be able to check the output whether it is correct or not. You can see that this one clicked here, so this is folks score 100%, this one 0%. So it looks more professional. So share via link, you can see that this one. Now I want to change this image. I want to see this particular object. Submit. Sports car convertible 11%, minivan 11%. So this interface is better. So if I want to share it, so now it is available all time. 24/7 it will be available on Hugging Face Cloud and it will be done. Okay, so simply copy and share by any mode. It is running. If I want to close it, even if I do not deactivate this particular space, then billing will not continue. In case of Amazon, other cloud, billing keeps on working. Okay, so share via cloud, this one link copied, and you can see that this specific link will be able to share. Okay. Is this clear to all of you? Kindly confirm. Are you getting this point? So this one, so for example, I want to show with some other like RAG application. Okay, so one RAG application, restart this space. If we want to create one LLM based application, RAG based application, that can also be done. So Hugging Face, so simply come to your spaces and new space. You can upload your own source code. If you want to take up a pre-trained model, if you want to take some existing model, okay, for example, some specific model I want to take from Hugging Face itself, like in speech recognition, in NLP, I want to work with question answering or summarization. For example, this one, okay, this summarization. Which particular implementation we want to take? We want to take Google Pegasus. Okay, this one. Okay, I want to use on in my own space. So one option is, as we have seen that we will upload our file, we will create a source code in this particular way. We will upload a source code and then it will work. I want to take this Google model as it is, deploy spaces. You can see that it is giving us option Google's deploy on spaces. Click on spaces. Okay, so you can see this one, create new space. Simply click here, create new space. Now in same way, Apache license, Gradio, public. Okay, it is my public URL. On cloud, it will be integrated, it will be compiled. After compilation, after checking each and every parameter, it will give me the interface and directly we will be able to use it. Okay, so it is executing now and very soon we will get its interface to use this particular platform. So it is executing now. So application startup. Now you can see it is running. So you can see that, for example, this one. Okay. Anything, any specific. or any text you will be able to take. For example, some random text I'm taking from internet, and this particular text. So submit inference provider, and its summary will be generated. So in this way, it is running. So whether it is a text summarization or any other implementation, if we want to upload our own script, if I want to upload my own code, that can also be done. So this one is running without giving our complete code, without giving our complete notebook. And moreover, it will be in better interface. Okay, so this one spaces, new space. For example, one more code we want to share. Okay, one more script I want to upload. This one. This is my app. This is my Python code. This is RAG based application. So this implementation is related to RAG, fine tuning of RAG, fine tuning of retrieval augmented generation RAG using FAISS. Okay, we are using sentence transformer. This code will be same, no change. These files I want to upload, I want to fine tune. Okay, in a pre-trained model, in a specific large language model, I want to give my own data. For example, at backend of ChatGPT, at backend of DeepSeek, whatever model is there, I want to train my own documents. I want to give my own documents. Okay, I want to give my own data. So these 4 sentences, these 4 statements, just for demo, I want to upload. And depending upon these 4 sentences, I want to put some question. Okay, so now this app I want to deploy on cloud. Rather than console, rather than command prompt or Google Colab, I want to upload. I want to take it. I want to use it on Hugging Face. Okay, so new space. Okay, RAG fine tuning. Create new space. Apache 2.0, and other things will remain same. Gradio and create space. After that, you can see that files. We will come to files. We will upload the scripts, contribute, upload files. Which files I want to upload? Where is my Python code? My Python code is here, app.py. Uploaded, commit changes. Okay, so either you will be able to commit changes via web-based interface, or you can link your GitHub repository. Okay. So second is requirements.txt file. In requirements.txt file, which packages we need to run this application? So in requirements.txt, this is also mandatory. If you will not upload requirements.txt file, then your code will not work, because in actual source code, which libraries you are using? FAISS, this FAISS. This one is transformer. This is your transformer. Gradio. Okay, torch, sentence piece. So whatever you have imported in your source code, in your Python code, those package name you will have to specify in requirements.txt file. Okay, and these packages will be installed automatically on the interface of Hugging Face. Now these files are uploaded. Requirements.txt file, app.py. Now I will click here for execution. Okay. Now on click of this, so it will download the required packages. So you can see installing collected packages, WebSocket, whatever it is. So you can see here this particular status, building. It is building, it is creating that particular repository. To execute this particular source code, it will download all packages it will download all libraries, and finally it will give you the web-based URL. It will be permanent. Okay, first of all your code will be secured, and your interface will be in a better presentation. Okay, for example, you are working on some research paper. In your research paper, you are giving some screenshots of web-based application related to your implementation. It will give a better impact, okay, rather than everything on console, everything in command prompt, in text mode. So if you are using some GUI based platform, then it will be better. So it is installing, and 1-2 minutes it will take to install all required packages, and finally it will give you the interface that this is your interface. This one is your GUI. Now you can see that one by one it is installing all packages on cloud, and everything is free. If same thing you will perform in Amazon AWS, I think some of you might have used AWS GCP. It is very in that particular case we have to pay for that. Okay, whatever packages we are installing, whatever instances we have started, whatever systems we have started, whatever services we have started, for everything we have to pay in Google Cloud, in AWS, in Azure. Okay, and you can't deny, because your payment credentials, your payment, your card details is already taken by that particular, by those platforms. But here, no need to link anything. Simply upload your code, upload your requirement.txt file, and everything will be done in Hugging Face spaces automatically. Okay, so you can see it is still building, and once it is done on cloud, now your cloud space is getting ready for this implementation, and it will give you a specific GUI to work with. So you can see that pushing image and building, and very soon we will get the link. So pushing image and this one. Okay. So for classical research based applications, we can use these platforms. After this debugging phase, I will show some more platforms also which are freely available. No need to link your card details. Okay, I'm showing you those platforms, those demonstrations in which no need to link your payment details. Okay, otherwise it becomes very problematic when we put some card details and we forget. So building, and after pushing the image, after getting ready, we will get our live URL. Okay, once it is done, then we will come to our next platform. Okay, so first option is Google Colab with Gradio. Okay, another option is Google Colab with Gradio with NGRock. Okay, NGRock is also available. NGRock, very popular platform to link your web-based application, to link your deep learning based application. But in this particular scenario, there is a certain limit. Okay, NGRock. So with multiple programming languages, you can work. With multiple platforms, you will be able to work. Mac, Windows, Linux, Docker, Raspberry Pi. You can see. If you want to install, if you want to link your Raspberry Pi, for example, you are working on IoT based application, and so Raspberry Pi with Python and with other platform, so you will be able to work with it. Okay, now it is getting ready. So initially when we launch some application on these platforms, then some time is taken, and once each and everything is installed, then you can reuse it any number of times. Okay, so this is another platform, your NG-Rock, and multiple interfaces you will be able to work with. Okay, this specific key we have to use, and then we will be able to work with it. Okay. So this one, and after that, which services are running. So this particular service is running, SqueezeNet, RAG fine tuning, it is building now. This one is running pre-trained. So you can see that 4 to 5 services are still running here. View 10 spaces. So how many applications we have created? So this RAG. So for example, this one, okay, RAG demo. Okay, similar to ChatGPT. For example, so where is, okay, Great Wall of China? Okay, for example, I want to ask this question. So this one. So from where it is getting the response? It is getting the response from this database which I have uploaded. So this one. If I want to ask about programming language, for example, in my chatbot, I want to ask about a popular programming language, okay, or prominent programming language. So what we have done, we have fine-tuned this particular pre-trained model. In this pre-trained model T5 small, we have put our own data, and after that we are asking some questions. Okay, prominent programming language. Submit. So you can see its context is Python. So from where it is getting the responses, it is getting responses from this particular data which we have trained. So these are only 4 sentences for demonstration. We can upload PDF files, we can upload our doc files, and after that we can ask some questions. Okay, and it is working on cloud, on free cloud. Okay. So one way is that output is on Google Colab, output is on console. Second way, second format, this one on web-based application on Hugging Face. For example, I want to ask about this one, Eiffel Tower. Okay, whatever data I have trained, where is Eiffel Tower? Submit. So you can see that it is giving this response. So similar to ChatGPT. So in ChatGPT, so many data sets are integrated. So similar type of application we can develop. We can train our own data, we can train our own paragraphs, and after that we can ask the questions similar to Gemini, ChatGPT, or any other thing. So that is RAG, Retrieval Augmented Generation. In existing language model, we are integrating our data and then asking the questions. Is this clear to all participants? Kindly confirm. Are you getting this point clearly? Whatever we have discussed so far, is it clear to all of you? So 2 files we have to upload. One is app.py. Whatever code you have written, it should be available in app.py format, app.py file. Second is requirements.txt. Now another platform, next platform we will discuss. This is also very popular, very prominent platform, cloud-based platform for deployment of machine learning and deep learning based applications. That is render.com. This one. No need to link your card details, no need to link your payment details. Okay, simply create account with your email ID, verify it, and start working. Start uploading your documents, start uploading your files, deep learning code, machine learning code, generative AI, whatever code you are having, whatever script you are having. Okay, for example, I'm having this particular app, this specific Python code. Okay, this specific code of machine learning I want to upload. Okay, I want to use. So simply this Python code we will upload on render. Either you can upload on render, railway also you can take, So get started. Simply sign in with your account, with your Google account. You can see that this one. This is the interface. Now I want to create a new project. Okay, if I want to view existing projects, that can also be generated. Okay, so this one. So create new project. Project name. Okay, so you can specify it. So different services we have already created. It is also a free cloud. So you can see that which regions we have taken. Oregon, this one. Now we want to add a new service. For example, this one. Click on new service. Which service I want to use? My deep learning application will be covered as a web service. If I want to work on static site, background worker, cron job, Postgres, web service. I want to deploy my deep learning, my computer vision based application or machine learning based application as a web service. Web service means a particular application on web browser. Okay, click on web service. Now what I will do, I will link my GitHub account. So this is my GitHub account, this one. Okay, so simply create your GitHub account, GitHub repository. In your GitHub repository, you can see that this is my GitHub account. Okay, in this GitHub, I have created multiple repositories. Okay, so for example, this machine learning code I have uploaded in my GitHub. This is my app.py index.html file. Okay, this is my app.py file. Now, this app.py file, which is uploaded on GitHub, I want to run it because GitHub is a code repository. I want to execute this code in form of a web service, in form of a web-based application. So I will link this GitHub account with render. So this is my GitHub account. So click. Okay, simply click here. Now it is asking me which Python I am using. Python 3. What is my branch? Branch main or master? Generally we have two branches, multiple branches we can create. So I want to see in which branch I am working. So you can see main branch or master branch. So you can see that. So currently, how many branches we are having? This one, main. Okay. In some repositories we can work with master. Okay. So if you are new to GitHub, some of the participants may be new to GitHub. So for those, I'm sharing how to create your own repository. For example, you have this source code. You want to upload on GitHub repository. So simply create account on github.com. After that, new. So you can see that, click on new. Create new repository, any name. For example, my ML code or my ML, anything, or pre-trained. For example, this pre-trained is available. This name is available. Whether it is public or private, create repository, add license, Apache license, MIT license, or no license. Okay, description you can give. Now we are creating new repository. So you can think repository simply as a folder. Okay, very simple. As a folder you can consider in layman point of view. Now I want to upload my files. So one way is that I will use some GitHub platform, some GitHub tool. Okay, or with a command prompt we can work. So git init, git add. So if you don't want to go for these commands, because some of you might be from other disciplines, from other domains, so simply click here, upload an existing file. Okay, directly web browser. No need to download any GitHub client. Simply choose your file. Which file I want to upload? This file. Okay, now this file is uploaded. Commit changes. Okay, so without any tool, without any client, now you can see In pre-trained repository, this app.py is available. Now this app.py file I want to run as a web service. This is my RAG code, RAG code. This RAG code I want to run as web service on web browser. So what I will do, I will come to render. In render, I will give name of that repository. Okay, your account name / repository name. And after that, free. So simply free. Okay, I have not linked my payment details here. And after that, deploy web service. Okay, once this particular web service is deployed, after that, it will be available here. Okay. So you can see that in this format it will run. In very fresh attempt, in first attempt it will take some time, 4 to 5 minutes in installation of services. So many logs you will see. Okay, and after that it will be available here in this format. Now it will be available all time. So this link is generated. Click. Now whatever code you have given on this platform, whatever code you have given here, it will run, it will be executed on render cloud. So I'm not doing anything on my local laptop. I'm not doing anything on my command prompt. Everything is done. Everything is getting executed on web browser, on web-based services, on cloud. Okay. So once it is done, then you will be able to see its results. So you can see this one. So services, so application loading. Once it is loaded, then you will be able to see the results. So you can see that incoming service request. Okay. And it is under free tier. So what we have done, whatever application you are having, whatever source code you are having in GitHub, we are running it as a web-based application in this one. Now you can see this. Now I will write here front end / front end. So you can see that it is running here. For example, this prediction 2. So you can see this one. So where I'm running, it is getting executed on render.com. From where this link is coming, this link is from here. Okay. Any number of services you will be able to create. Okay. After working, so at backend it is working with Linux platform. So you can see that on cloud I'm executing sudo command. You can see that sudo suspend web service ml2 on cloud, not on my local command prompt. Suspend web service. Now it will be suspended. At backend of this there is Linux. I want to open this web service. Resume. Okay. So now it is deployed. Now on click of this, resumed. Okay, click. This is my web service that is linked with my GitHub account. So any number of repositories you will be able to create on GitHub, and those repositories you will be able to link with your render account, with your railway account. Another platform is railway. You can explore it. It is also providing free account. Okay. So you can see deploy a new project on railway. So meanwhile it is working. I'm showing you this one. Okay, so you can see that this is railway project, new project, GitHub repository from where I want to take my code. My code is available. My code I have uploaded here. My script I have uploaded on GitHub account, this one. If you want to add new files, so you can click create new. Okay, so new file you will be able to create. Okay. So you can see that this one, create new file, upload file. If I want to update this code, if I want to change this particular code, for example, this code I want to change, click here on web browser. If it's up to you whether you want to use some client or not. GitHub clients are also available. Otherwise, this is the easiest option. On simply edit this file on web browser itself, you will be able to edit. After editing, commit changes. Okay, commit changes or cancel changes, whatever changes you have done in this file. And once this particular file is updated, then you can call it in your render or railway. For example, GitHub repository. Now it will ask which GitHub repository. Okay, so I will give name. Okay, /ml, whatever GitHub is there. Login with GitHub, or I can simply click here, login with GitHub. It will automatically link with my GitHub account. This code will be imported here. Okay, this code, whatever code I have given, for example, this one. Okay, this copy and paste. Whatever code is available in this particular repository, in this specific account, it will be linked in my cloud, in railway cloud, in render cloud, and then we will be able to execute this one. Okay, as a web-based application. So login with your GitHub account. So it's up to you whether you want to use railway or render or Amazon, but if you go for Amazon or GCP, in that case, there are lots of issues related to payments, lots of issues related to payment integration, card details. Okay, because most of the services are paid. Even free tier we have to we generally use with some panic that some particular payment should not be deducted, some payment should not be charged. But on these platforms there is no issue. Any number of times you will be able to deploy, and also and similar type of services available. Okay, whatever you get in Amazon, same type of services you get here. For example, I want to suspend it. Click now sudo suspend. Copy this command. Okay, sudo suspend web service, and now it will be suspended. Okay, even if you will not suspend, even then nothing will happen. Okay, no billing will be there. In case of Amazon, if you will leave running services, leave the services running all time, or simply I sign out here in Amazon and services are running, in that case, in charge is associated. Okay, so we have to take care these things very carefully in other platforms. So it is only for demonstration. I'm not promoting any platform, because for implementations, for demonstrations, I generally use those platforms in which no need to link our payment details. Okay, so I'm giving you a quick recap because it might be looking some complex. For example, you have created account on GitHub. Come on repositories. In repositories, simply click new, create new repository. Okay, any name you can give, as simple as creating a new account. For example, this is deep learning or computer vision. In computer vision folder, for example, this is my folder. I want to upload some files on which are available in my local laptop, in my local system. So add files. Okay, upload files. All of your scripts will be uploaded. Now I want to use these files. So whatever files I have uploaded in my GitHub account, I want to use, for example, this is my data set, data.csv. This one is app.py file, Python file, requirement.txt. Now I want to use this app. I want to run this app in web browser. For that, we need render, railway, Amazon, GCP, Azure, whatever it is. Okay, so I am coming to render. simply new service, web service. Okay, it will ask you, okay, from which account you want to take. So this one, GitLab, Bitbucket, other platforms also available. Okay, from GitLab, from Bitbucket or GitHub. So I'm using GitHub account. So this one. If I want to change it, so if I want to verify it, so add it. For example, I want to take this one slash. For example, this is RAG app, RAG-app. Okay, so we can work on that. This one, authorize, configure in GitHub, and this one. Okay, if I want to check the source code, which source code is available, click here. It will move to that particular folder in GitHub, in that repository. Now I will verify, okay, this is the code I want to run on cloud. So after that, free tier, I will take this free tier. Okay, and then deploy web service. Very quickly you will get this type of web service running, and then you will be able to execute. Okay, very simple. Everything is on cloud. Even no need to install TensorFlow, no need to take graphic card, no need to take GPU, TPU. Everything live on cloud because of the performance. Otherwise, on local laptop, you might have seen we face so many problems. This is not installing, this dependency issue, this troubleshooting, this DLL file is missing, this particular package is missing. So in local laptop, in local installation, we face so many problems. Okay, but on cloud, everything is available. Everything is up to date. For example, we are using Windows 10. Some package is not compatible with Windows 10. Then also it becomes very problematic. It becomes a headache that it is not compatible with Windows 10. It is not compatible with Linux. It is not compatible with Fedora or Red Hat. So leave your code, execute your code on cloud, and your code, your script, your execution will retain permanent. On your mobile phone also you will be able to access it. Okay, so you can use these platforms, cloud-based services for AI-based applications. Such type of applications you will be able to deploy very quickly. Now, dear participants, I am sharing some scripts. Okay, in this particular presentation, I have not used any PPT. So for your practice, I am giving you some scripts which you can use, which you can upload on render, which you can upload on your GitHub account. Okay, one collab notebook also I am downloading so that you will be able to work on it. ML Cloud. Cloud notebook also I am sharing. This you will be able to import directly. PYNB file, and wait. Now, dear participants, link of the code I have given in chat. Simply click and is it downloadable to all of you? Kindly confirm. Simply click on the link given in chat window and kindly confirm, is it downloadable to all of you? And whatever we have discussed, is it clear to all of you? Is it was it understandable or not? Kindly confirm, so that we come to know that how much you are able to adopt, how much you are able to imbibe the concept or implementation parts. Any query you can ask.
Sir,
Yes,
I
yes,
have
ma'am.
one
Yes.
question. That in
Yes.
a radio, we are able to generate a public URL.
Okay.
Is it possible same thing in a render in railway?
Yes, yes, definitely. Actually, in render that I have shown you, automatically a public URL is generated and it is permanent. Okay,
Okay.
that link will be generated once you deploy one app.
And sir, other question may not be related with this topic, just as per my curiosity. Is it possible this platform allows Android files to code or not?
Yes, yes, definitely. On different platforms, you will be able to deploy. If you want to execute it on smartphone, that can also be done. Its Android app can also be created.
Okay. With the same
Okay.
platform or platform is different?
No, no, same code will be used. It will be executed on smartphone as well as on browser application, any browser application.
Okay, means what I mean to ask that if I am generating some Android app in a Java code,
Okay.
is it allowing Java code also
Yes,
by
yes,
the
definitely.
platform?
Yes, yes, definitely.
And
Within
is it
Java code also.
generating? Huh?
Yes,
Is
in
it
Java code also you can import it as a API. Actually, on render, if you will go for APIs, so this web service will be available as API.
okay?
And
Okay, sir. Thank you so much.
and there is one query that app.py question mark. Actually, whatever code we want to run on cloud, it should be saved in app.py file. It is only a convention. Okay, app.py file.
Hello, sir.
Yes, sir.
Can I speak to you?
Yes, sir. Please ask your question.
Sir, it is 8:48. I think I'm disturbing you.
No, sir. No, not disturbing at all. Kindly ask your question.
Sir, is it possible to convert a IPNF file to PY file?
Kindly repeat, sir. Which file?
Google Colab file, but that is IPNY file to PY file.
Yes, yes, definitely. There are no actually. If you have some IPYNB file, uh, the, some particular script you can copy. Otherwise, within Google Colab also there is option to download as .py. Okay, there are two options. One is to download as .pynb file. Another is .py. Otherwise, what you can do, there are so many online transformers available, online converters available. So that IPYNB file will be converted to PY. And once that PY is available, then you can save it in app.py file. Then you can upload it on Railway, on GitHub, on Render, or whatever cloud.
Sir, you are great. One question, another question, then I will stop to asking you to disturb you. Convert the PY
Please
file
ask,
in
sir.
executive file.
Sir,
Any
kindly repeat.
option is there?
Okay.
Any option is there to convert PY file on a Python file to be converted in executable?
Yes, definitely. PY file can be transformed to exe file. I think this is your query. You want to generate exe file. There are certain packages available. Okay.
सर
PY
मुझे
to
नहीं
exe.
पता कैसे करना है सर
Okay.
मुझे
PY to
बता
exe.
दीजिए सर मुझे कौन सा स्क्रिप्ट है मुझे बता दीजिए
Okay. I'm sharing
सर
this
कौन सा
particular link. So, sir, this link I am
सर
sharing in chat window.
सर आई हैव डाउनलोडेड दिस बट आई हैव डाउनलोडेड दिस सर मुझे ये बताइए कि पीएफ फाइल को आईपीएफ फाइल को किसे एग्जीक्यूटिव फाइल कन्वर्ट करना है
Yes, yes. Actually, sir,
आई
this is the link. So this, sir, what you can do, whatever code you want to convert to exe, you can discuss with me after this particular session. Okay, during this particular
ओके
session, so I'm taking queries, and if you are working on some specific task, you can mail me separately. Then that particular troubleshooting I will accept. I will take.
सर वो तो नहीं पता आपको मेल तो एड्रेस नहीं पता आपको
Mail
मेल एड्रेस
ID.
नहीं पता मुझे
Okay.
मुझे नहीं पता
Okay, I'm sharing my mail ID. If you have if you need some troubleshooting, you can mail me. I will see where you are facing some problems, and I will try to troubleshoot it.
Okay, sir. Thank you, sir, and giving me the time. And I'm disturbing you, I think. And you give a lecture for the 1.5
No, sir, not
hours.
at all.
I think you were tired. Sorry, sir.
No, not at all, sir. Please, you are welcome, sir. So this one and
Okay,
half
sir.
hour was only for you, okay, not for any other task. I am here for this particular session in this particular time span only for you, only for your queries and coverage. Any
Sir,
other query from participants? And how much you have understood? Is this clear, or it is looking difficult?
Sir, is it clear? But when I went to AWS, the language was kind of hide and PySpark. That I don't have the platform. How to do the command line interface in AWS in hide language and PySpark? But sir, I do not understand. They are taking the money from me, and I give the storage from AWS S3 matters. But after 1 month, they stopped the storage.
Yes, sir. Actually,
Storage,
on
data
AWS,
storage.
sir, I got your point. Actually, on AWS, on other cloud, there are so many issues related to billing, related to some services. Okay, and because specifically new researchers, they are not aware how much they are charging. It looks that they are charging $0.0001 per minute or per second or per hour. We think that okay, it is only 0.001, but that particular $0.001 per hour, it becomes a big amount even in few days. Okay, and then they suspend the service, they can terminate the account. So what we can do, we can take some alternate platforms, some alternate services. Okay, so I'm not against any platform. I'm not saying that this is good or this is not good. I'm discussing in terms of monetary values, in terms of ease of use. Okay, because I also use some alternate platforms where billing is not an issue. Otherwise, our focus will be on only on billing rather than on our own work. Okay. Any other query?
Can I ask you the last question?
Yes,
Yes,
sir,
sir.
definitely.
Can I
Please
ask you the
ask.
last question?
Yes,
Sir,
sure, sir.
what is the use of data center?
Data center, actually, in cloud computing, we have data centers for storage of data as well as services, as well as running services. Whatever we are doing, for example, on render, on AWS, whatever you are storing, that particular storage is done in data centers. Okay, in data centers, there are disks, bare disks, which are connected with different APIs, with Docker. Okay, which are connected with front end in form of containers. So whatever process we are doing, for example, I am executing one code, I am creating one web service. That web service is actually getting connected to that data center. That particular data center is having each and everything. Okay, we are working only on web browser, but at back end of web browser there is data center, and in data center there are so many machines in which different operating systems, different platforms are available, which are working at the back end.
Okay, sir. Thank you, sir.
Yes.
And sorry for to disturb you.
Okay. No problem, sir. Any other query? Any other
No, sir.
participant?
No, sir.
Okay. Any other participant who wish to communicate?
Hello, participants. If any participants have any question, they can ask the experts.
Any other query? If you have any query, you can ask.
So, sir, if there is no any query, so we can conclude the session here.
Yes, sir. Fine.
Okay. Okay. Thank you, sir. So, sir, kindly share the course and other PPTs also.
Yes, sir. Sure.
Okay. Thank you, sir, for your
Thank you,
nice
sir.
deliberation. Thank you.
Thank you, sir. Thanks to all participants.
Okay. So now we conclude the day 2 sessions here, and tomorrow again we start the session at 6 p.m. Okay. Thank you.